Hello everyone, this is your Cisco trainer and welcome you to the lecture number 3 from the course CCNA 200-301. In this lecture, we will cover all aspects of OSI model reference and TCP IP suite. Sometimes people are called TCP IP stack as well. We will go through 7 layers of the OSI model reference in details. And if you haven't already not subscribed to my channel, stay tuned please by just clicking on subscribe button, hit the buzz and thumbs up for more great videos. What is OSI model layers? Why network engineers are using OSI model layer? OSI model layer helps the engineers to understand communication over a network. What is network? Network is a combination of hardware and softwares, or a computer network is a connections of network device to data communications. Multiple networks are connected together to form an inter-network. The challenge of the inter-networking is interoperability between products from different manufacturers require consistent standards. Network reference model were developed to address these challenges. Two useful reference models are OSI model reference and TCP IP serve as a protocol architecture details to communicate between applications and network devices. Troubleshoot easier by separating function into different network layers. Help you understand new technology as they develop. Allow you to separate primary functions relationship on a various networks. OSI model reference established in 1947. The International Standard Organization ISO is a multinational body dedicated to worldwide agreements. An international standard, an ISO standard that covers all aspects of network communication, is the Open Systems Interconnections model. It was first introduced in the late 1970s. Before OSI model layer, there was lots of problems to make connections between different vendor or different computer from different vendor, because each computer or each products from each different vendors use its own language and protocols. Here we have computers from two different company. In the left hand we have a Dell computers, and the right hand we have an IMAX computer. They try to communicate with each other, but unfortunately with the lack of OSI reference model they are not able to communicate with each other. So this is the beauty of OSI reference model, to enable interoperability between different vendors. Nowadays all the network engineers can connect different computers with each others by the help of OSI reference. The OSI reference model is a structure model, and all the network engineers have to have used the structure of the OSI reference model. OSI reference model is including 7 layers. Each layer has its own function and responsibilities on the network. So we have a 7 layer of OSI model reference: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layers. You have to memorize all these 7 layers, including its job and functionality. So there's 2 acronyms for memorization of these OSI model reference. If you memorize from top to bottom, or if you memorize from bottom to top, all applications seems to need data processing. It is from top to bottom, or if you want to memorize from bottom to top, please do not throw sausage pizza away. So OSI model reference is divided into 2 parts. The first 3 layers of it is called upper layer, then programmers or the developers are involved, and also the 4 bottom layers, transport, network layer, data link, and physical layer. The network engineers are involved with these 4 layers. So when the programmers they try to set up its application, they are busy or they're working or they're involved with the upper 3 layer of the OSI model reference. The first layer is physical layer. What's the job and responsibility of the physical layer? The physical layer is responsible to send bit from one node to other, and what data is called for each layers. In a physical layer, the data is called bit, and the next layer is the data is called frame. In a Cisco term we say frame or packets, and also the third one is called packet and diagram, and the 4th one is called segments and packets. All these 4 data is called a PDU or packet PD protocol data units. So it also we have an acronyms. If you want to memorize, so someone is called, I have a problem in a layer 4. So you don't know what is the data is called in a layer 4. The layer 4 data is called segments. What is segment? We will have a separate section on it. So seen people for birthdays, S for segment, P for packet, F for frames, and birthdays for bits. And also from bottom to top, babies find puzzle segment. If you have some other acronyms, so please comment on below, we will use for the next. And also what is called segment. This box is called a segment. What do we have inside the segment? It is called packet. And what we have inside packet is called frame. And what do we have inside the frame? It is called a bit. So when we send data, data is in a physical layer sent in the form of bits, and in a second layer the data is called in form of frame, and the third layer is called in a packet, and the fourth it is called as a segment. Physical layer. The physical layer responsibilities for movements of individual bits from one hop to the next. I illustrate here from two difference. Either the data is came from upper layer, or either data is go from first layer to top layers. So when data is reached from data link layer to the physical layer responsibility is to move bits from one network or from one hop to others in a form of bits, in a form of electro signals. So all the cables and the job of the physical layer is transmissioning bits from one node to other. In this diagram, the data is came from the data link layer to the physical layer, and the right side the data is goes from physical layer to data link layer. Also, what is called data in data link layer? So the data link layer is responsible for movement frames from one hop to another hops. But when data is reached from network layer to data link layers had it is header and also trail. The trail is used to determine whether the frames arrive without error or so. Then we can send data from both sides. I illustrate data from both sides. Either the data is reached from the top layer to the bottom, or from bottom to top. The data link layer is used in hop to hop. So here I illustrate the hop to hop. How network is, how frame is passed from one network to other. Client A is trying to reach to client F. So the data is came from A to B, it is one hop, and from B to E, it's another hop, and from E to F, it is the third hop. In a data link layer, the data is moved from hop to hop. So the responsibility of data link is to move individual frame from hop to hop, transferring belong to data link layer. Network layers. The responsibility of the network layer is delivery of individual packet from source host to destination host. So here we use when data is reached from transport layer to the network layer is add its headers, and the complete data and the network layer is called packet. Then packet move to the network layer, from network layer to data link layer, from data link layer to transmit over to the other, or to physical, from physical to other layers. So when data is came from transport layer to the network layer are its headers, and also these combination of data in a network layer is headers plus data plus these data is called packet. Now transfer or move to the network layer. Network layers move to from transmissions made them to other side to the neighbors. And as we said, the network layer responsibility is from source to destination. So in this diagram, I will show you, I will illustrate to you how data is moved from source to destination. Network A tried to reach the network or to the client F. So the data is came from this source of A to the B and from E to the E. This is a complete illustration of how data is moved from source to destination. Source to destination delivery is responsible for, or it's responsibility of the network layers. What is the responsibility of transport layer? Transport layer is responsible for delivering of a message from one process to another process. So when data came from session to transport layer, and from transport to network layer, and send data to the other side. The responsibility of a transport layer is a process to process. And here, when data is rich, the data is divided into different parts. The responsibility of transport layer is segmentations, flow control, and error control. When you're accessing the data, if there is some data is missed, so it is the job and responsibility of the transport layer to recover it. And also it's a flow control. When you're accessing data from a computers or a small device like a mobiles, could be the huge of the amounts of data is huge. And the PC or the computer or the mobile will not be processed such amounts of data. It will pass a message to the transport layer and ask him, please slow down. This amount of data is too high, so I cannot able to process. And also a flow control and error control checksum, they are the responsibility of the transport layer. So this diagram will show you how to process communicate, how to process delivery of the transport layer. And at the left hand side we have data. So the first layer is a network layer, host to host delivery, and the last one is the fourth layer is a transport layer, process to process delivery of the data between two different or two networks or two computers. So this is the responsibility of the transport layer. What's the session layer? The session layer is, in simple we say session is a setup. It helps the network to make a setup, or the session layer is responsible for dialog control and segmentation. The session layer's responsibility is session management, authentication, and authorization. When you're trying to access a web, so first try to pass a username and password for authorization. When the computer or the server authorize it, then it will pass you a data for you. So the responsibility of the session layers are segmentation or synchronizations. When data is rich from presentation layer to session layer, the session layer is pass data to session layer pass to transport layer. And these four bottom layer, which is responsible, which belong to network engineer, in each layer we have separate name for data. For example, in a physical layer the data is called bit, and for data link layer the data is called packets, and for the network layers the data is called frame, and for the transport layer the data is called segment. This network will illustrate it as well for you guys, how data is came from presentation layer and how data is moved from session layer to presentation layer. Presentation layer. What is the responsibility of presentation layer? Presentation responsibility is to translate compression and encryptions. When the data is came from application layer to adjacent layer, presentation, session, transport, network data, and physical layer. In such a manner, data is called encapsulation, and when the data is reached the neighbor side and neighbor side open, it is called a decapsulation. The responsibility of a presentation layer is translation, compressions, and encryptions. So when the data is reached to a presentation layer, it is translate from ASCII code to EBCDIC. So computers or all digital devices just know a binary or EBCDIC codes. So, and also the responsibility of a presentation layer is a encapsulation. Compression. The compression maybe sometimes it is a loosey or it's a looseless. Example like SSL, secure socket shell. But also the data is encrypt and decrypt. These three functions are the responsibility of a presentation layer. So data is moved to the next layer or the adjacent layer and then transferred to the neighbor. So when data is came from the neighbor side, so it is a decapsulating. When we send data, it is called encapsulation, and when we receive the data, it is called a decapsulation. And also in here we have a H6 or header of the layer 6 with the data. What is the function of application layer? Application layer responsibility is to provide service for the end users. So here we use application protocols, not application layer. The application itself is an OSI reference model application layer, but we use network application. So what do you mean by network application? Network applications mean we use HTTP, SMTP, FTP, NFS, DHCP, FMTP, POP3, NNTP, IRC. These are the protocol of applications. So when we search a web, so it is the job and the functionality of the HTTP, or when we send a file, it is the job or responsibility of FTP. So in application layer, all the data is present for the user is the job of application layers. Again, as I mentioned already, when we send data from application to down to the physical layer, this is called encapsulation. But when we receive data from physical and open it to the application, this is called a decapsulation. This is the process of OSI model reference. So it is the summary of the layers. Application layers to allow access to network resources. Presentation, translate, encapsulate, and compress data. Session is to establish, manage, and terminate sessions. Transport to provide reliable process-to-process match delivery to error recoveries. Network to move packet from source destination to provide inter-networking. And data link layers to organize bits in a form of to provide hop-to-hop. And physical transmit bits over medium to provide mechanical and electrical specification. So this is the complete summary of the OSI reference model. What is TCP/IP model? And nowadays, even people are not, or engineers are not using OSI model. They are using a TCP/IP stack or model. TCP/IP model and OSI reference model both are a structure. A concept. It's a conceptual structure. The network engineer use it in order to not face any problems. So we not mention about the application or name of the layer. So if the network engineer face a problem, he will call or he will ask the network engineer, I have a problem in the network layers. They're not mentioned the network layer. He will ask, I have a problem in layer 3. So what is the layer 3? Layer 3 is a network layer. So what do we have in layer 3? The protocol IPs. So in a right hand we have an OSI model, TCP/IP stack. In the left hand we have an OSI model reference. So the first three layer, application, presentation, and session layers called application in OSI in TCP/IP stack. SMTP, FTP, HTTP, DNS, and SNMP, Telnet, and so on. These are the responsibility of application layer in OSI model reference. And also these three layers combine, it is called application layer in a TCP/IP stack. So transport layer is a transport layer. The first three layers are combined, and the others, each one is do its function separately. Transport layer's responsibilities is CTP, TCP, UDP. So transport layer use both protocol connection oriented and connection list. This is the responsibility of transport. So what's the network? Network is called sometimes in TCP/IP model internet. ICMP, IGMP, IP, RARP or ARPS, that's the responsibility of internet or network. In a TCP/IP stack, the two bottom layers sometimes called singles, physical link, but in an OSI model layer we have a data link layer and physical layer. In a TCP/IP model we have only one layers. Protocol of defined to underlying network host to network is the difference. The most difference are the complete difference between TCP/IP stack and OSI model reference. But nowadays network engineers are use TCP/IP stack. Relationship between layers and others in TCP/IP stack. Again, in the left hand we have TCP OSI model reference, and the right hand we have a TCP/IP stack. Application, before as I told you, the three upper layer of the top layer of OSI reference model is combined into one. It's called application layer in a TCP/IP stack. So in TCP/IP stack we have a process specific others, and the transport layers do separate its job. It's SSTP and TCP UDP. It's or port other. This is responsibility or the shared layer between others of TCP and OSI reference model. Network layers, IP and other protocols like logical others, TCP/IP. We will have a separate section on IPv4 and IPv6 as well. And the bottom layer is a network layer, and physical layers underlying physical network. It's a physical address. So this is a complete information about TCP/IP and OSI model reference. And if you have any questions, feel free, please ask me and share the videos for more great tips. Thanks for watching. and hope it's informative and useful for you.